Calculus 2 course. Some colleges they call it Math 112. It has different names. Uh, anyway, Calculus 2 consists of 4 essential units: Unit 1, Unit 2, Unit 3, and Unit 4. Unit 1 is Review Calculus 1. It includes limits of functions, derivative of function, integrals, and application of derivative. Unit 2, which is applications of definite integrals. Unit 3, integrals and transcendental. Unit 4, techniques of integration. In Unit 1, we're going to have a quick review for Calculus 1. Includes limits, derivatives, the applications of derivatives, integrals. First, you get to know the limits of functions in different ways. So I brought for you a perfect example to understand limits and not to confuse between the limits and the value of the function. So having this rational functions, f of x equals x squared minus 1 over x minus 1. If I ask you to graph, and before you graph, I ask you, how do you imagine this function looks like? Some of you will tell me it's quadratic, or it's linear, or it's cubic, it has curve, all these answers. If you look at this function, you will tell me that this function will be linear. Why it will be linear? First, if you factor x squared minus 1, it will be x minus 1 times x plus 1. When you divide it by x minus 1, then we cancel out x minus 1 with x minus 1. So x plus 1 left. So if you graph the function, it will look like it is x plus 1. It's linear. But actually, it's supposed to have gap. Unfortunately, graphing calculator doesn't show us this kind of graph. You see, it will be linear like this, x plus 1. But it has gap when x equals 1. Why it has gap when x equals 1? Because if you take the denominator, it will give me the restriction of this function, restrictions. So some way around x minus 1 shouldn't equal 0. So x shouldn't equals 1. So when x equals 1, the function has no value, doesn't exist. This function doesn't exist when x equals 1. Other point, yeah, it has values. There is a gap over here. We'll talk about later. So what difference between the values of the function or the value and the limit or the limits of the function? Let's see that. So we'll try to bring this graph over here, and we will draw vertical line. So let's lock it. We'll draw vertical line, go through this point over here to know our bounds, and assume that we have a point, and this point is moving along this curve, along this line. One of you tell me it's not curve, it's line. In general, it's curve, but it's line. It takes linear equation. So from left side of this is the left side over here. From left side, if this point it goes that way, it will approach x equals 1, and it will approach the value 2. So when x approaches 1, doesn't equal 1, no, approaches 1, goes close to x equals 1 over here, the function go closer and closer to the value of 2. Here is 1 over here. This is 1. 1. So when x from left side, the value of x come closer and closer to 1, the value of the function come closer and closer to 2. It has 2. So the limit from left side is 2. And from right is the same. This point is moving along this line. So when x comes closer to the value 1, it will be the value of the function will come closer to 2. Here. Come closer to 1. Come closer to 1. The value will be 2. Almost 2. So the limit from right side is 2. So limits of the function, let's organize our information. As you see, this formula for the limit here, limit of the function when x approaches c equals L. So let's do that here. So we'll say limit of the function when x approaches 1 equals what? 2. Equals 2. And this is from left side and right side. Let's do that here. Limit of the function when x approaches 1. Little negative at the top here to tell us we are on the left side. Equals the limit of the function when x approaches 1, little positive at the top here to tell us that we have the limits from right side. Both limits from left and right equals 2. So the function, the limit of the function equals 2. But when we have this expression, find f of 1 does not exist. Got it? Okay. Let's go deeply to understand the limits and what difference and between limits and values, and you don't have to confuse. I brought this table for you, graph. If you want to graph our rational function, f of x equals x squared minus 1 over x minus 1. Using graphing calculator. Here, using the graphing calculator, we could graph that over here. Here's quick. If you want to graph it, open x squared minus 1, close, divide by x minus 1, and then graph. Here is our graph. You cannot see the problem with graphing calculator, not Dismos graphing calculator, not any other website or software. That it doesn't tell us that we have gap over here when x equals 1. Unless you insert the value of x plus 1. So let's insert the value of x plus 1. So insert value number 1 here. So when x is 1, enter. Nothing. Y is nothing, doesn't exist. Let's do it with the value of 0.99, closer to b1. It's very close to b1. It has value. Look, it's 1.99, close to b what? 2. So x close to b1, y close to b2. You could insert different values here. So around 1 here, insert 0.999, it will tell us 1.99. Insert 1.01, close to b1, it's 2.01. 0.99, it will be 1.9. All all will be closer to the actual value of the limit 2. About 2. About. That's 1.01. We can say 1 equals 2. No, it has no value. It has gap over here. That's the rational value property. Always we have, or most, not always. Sometimes if this sign is different, then it will be like x, let's say x squared plus 1. We'll never have gap over here. We'll talk about later. Okay. Another thing I want to show to you, just to understand more and more and more about the limits. Using, thank you for smart notebook software. Here's the difference between the 3 graphs over here. We have 3 graphs, 3 different graphs. The first one, which is our rational function, x squared minus 1 over x minus 1. And you see we have gap over here. We have gap. The function when x equals 1 doesn't exist, but it has limits from left and right, which is 2. When x equals 1 from right or left, when x approaches 1 from left or right, the value will be closer to be a 2, equals 2. And over here, we have step function. We cover this gap by another point, but not in the same line. Not in the same line. It has different value. So we have 2 steps. First is a rational function, and we know that we have gap at x equals 1. And we cover the gap here. When x equals 1, we make it equals 1 here. So this function kind of crazy, because when you come closer to 1, you jump over here to have the value. So we will say the value of the function over here, when x equals 1, it's 1. F of 1 equals 1. But the limit of the function, when x approaches 1, it will be 2. This kind of example C, we have another point, and this point included in the same line. It's in the same line, lies on the same line. And it cover no gap. It has no gap over here. H of x equals x plus 1. H of x equals x plus 1. If you plug it in 1 plus 1 is 2, clear that the limit is 2 and the value of the function is 2. Later we'll say this function is continuous. Later when we talk about continuity. That's for this video.